Hi there, science students. In this video, we're going to be learning to calculate the number of moles from a given mass of a substance. That substance could be a pure element or a compound of some sort. The ones we're going to work on here are all compounds. So this is going to involve us using the second equation that we've learnt about moles. And because we want the number of moles, we have n as the subject of the equation. And that's going to be equal to the given mass, m, divided by the molecular mass of the substance, capital M. So we've used this equation in a question previously. That was question 6 here, where we were finding the mass from the number of moles. What we're going to be doing here is like question 5, where we're given a mass and we go backwards the other way and calculate the number of moles. So after this video, you can have a go at this question in the booklet. And that's the yellow booklet. But first, let's go through these examples. So we've got 4 chemicals here, all of which you'll be expected to know what the chemical composition is for each of these. At this stage, perhaps sulfuric acid, we could pardon you for not knowing that. We could forgive you for not knowing the chemical composition of sulfuric acid, but by the end of the unit you should be able to recall that one. But right up here at the top is water, and I'm sure that you'll understand that this is H2O. Okay, so the first job here is to figure out what is the relative molecular mass of water. And to do that, we can go to the periodic table. All right, so we want to take each of the elements and figure out their relative atomic mass, and then we add all those up to get the relative molecular mass for this chemical. So in the case of water, H2O, if you look at the periodic table, you can see that we have 2 hydrogens, and the relative atomic mass of each hydrogen is 1. I know the periodic table says 1.01 or 1.008, but for the purposes of these types of questions, we can just round to the nearest whole number for something that's so close to 1. And so there's 2 lots of those, plus the oxygen, 1 lot of oxygen, and they are 16 each. So if we add that all up, we find that the molecular mass of water is 18 grams per mole. So to show this with a particular notation, we'd use the capital M, molecular mass, and in brackets have H2O to show that we're finding the molecular mass of water, and that's equal to 18 grams per mole. Okay, so we figured out that capital M. So all we need to do now is divide the given mass, 150 grams, by that molecular mass. So once again, I'll use that notation, number of moles, N bracket H2O, to show we're finding the number of moles of water involved. And in this case, it's equal to 150 grams divided by 18. And if you put that into your calculator, you should get 8.33 recurring, which will go to 3 significant figures, 8.33 mole, like that. Righto, so at this point you might want to pause the video and try this for butane and sodium chloride at the very least, and even sulfuric acid. You can always Google the chemical composition of sulfuric acid and find out what it is, do some research of your own. But once you've had a go at that, replay or push play again, and I'll have a go at finding the number of moles for each of those different substances. Okay, so I'll have a go at it now. Righto, so butane. So the molecular mass of butane, which is C4H10. So we've got 4 lots of carbon, which are 12 each, plus 10 lots of hydrogen, which are 1 each. So 4 12s, we get 48, and 10 makes 58 grams per mole. Alright, now we've got 200 grams of butane, so the number of moles of butane, C4H10, is equal to 58, beg your pardon, 200 divided by 58. 200 over 58. 200 divide 58 gives us, oh, that's not right, 200 divide 58, 3.45 moles. Of butane. Sodium chloride. So the number, or the molecular mass of sodium chloride, NaCl, equals, okay, so the sodium chloride 22.99, and we'll just say 23. Now the chloride is worth 35.45. Now that one we are going to need to just leave as is. So what does that give us? I'll just try and do that in my head. 58.45 grams per mole. Okay, so then we take our 50 grams. So the number of moles of NaCl. We have 50 grams divided by the molecular mass, 58.45. So 50 divide 58.45, and we've got 0.855 mole to three significant figures. Of sodium chloride in 50 grams of sodium chloride. Okay, last one. Did you get the chemical composition of sulfuric acid? Well, I'll reveal it here in the molecular mass. H2SO4. Okay, so 2 lots of hydrogen plus 1 lot of sulfur, 1 by 32.06. Oh, look, you could probably call it 32, but I'll stick with the 0.06 here. Plus oxygen 4 by 16. So in total that gives us 2 and 32.06, 34.06 plus 48. So 32.06 plus 4 lots of 16, not 48, sorry. Much more than that, 64, isn't it? 96.06 grams per mole. Okay, so 20 grams, number of moles of H2SO4. We've got 20 grams of that stuff divided by 96.06 for the molecular mass. So 20 divide 96.06 gives 0.208 mole. Okay, everyone, so really a two-step process. Calculate the relative molecular mass, or the molecular mass of the substance, by going to the periodic table and then taking the given mass and dividing it by that number. So go ahead now, this is the question that we've set in the description for the video. Have a go at that one.